Okay, for part 2 here, we're going to look at two concepts that you've done in geometry with degrees, and we're going to apply them with radians here. So first thing is arc length, which is basically just a ratio of circumference that you've done in geometry. Here's your formula. S, which is arc length, okay, it's a new variable we introduced, is just radius times theta. The theta has to be in radians, okay, that's how these formulas come up, okay? Now, you don't just want to see an equation and not know where it comes from. So take this picture here. From geometry, you guys know that these central angles are going to correspond to the arc length. So if we say central angle theta over central angle theta 1, it's going to create some ratio where it cuts out proportional parts on the circle. Okay. Now, if you let this one here be 1 radian, okay, so theta 1 cuts out exactly 1 radian. If this cut out 32 degrees, you would know this cuts out 32 degrees. So now if we're in radians, okay, that means that cuts out exactly 1 radian, which is just going to be our radius here. So we're going to say, if this cuts out 1 radian, this just goes to the radius r. There's your formula for arc length. S equals r times theta. Okay, might be a good extra credit question. Here's a problem that you'll see, problem sets for quizzes, tests, whatnot. So you get a minute hand of a clock, 7.5 inches long, and we want to figure out how far it goes in 35 minutes. So we're trying to find that arc length basically to there. Okay, a few different ways you can do this. I'm going to pause it and show you one way here. If you guys want to try the same, go ahead with that. Okay, here's how I approach this problem. So we know clearly it's an arc length problem, so S is r times theta. We already have the radius, so that's not a problem. We need that theta. Okay, we can't plug it in degrees. We actually don't even have the theta right now. So if it moves 35 minutes, so it's a proportion of an hour, a clock is 360 degrees. So we just moved 210 degrees from here to here. That makes sense because 12 to 6 is exactly 180, half of the circle, and then a little bit more. Now you can't go plug 210 in there because the formula says we have to be radians. So we practice another conversion here. So 210 times pi over 180 comes out to 7 pi over 6. Within a couple weeks, you should be able to see 210 and know it's 7 pi over 6. Okay. Now, when I go plug in that 7 pi over 6, it's really up to you how you want to give me an answer. I usually leave things in terms of pi just because it's cleaner. But if you throw in the times 3.14, that's perfectly fine too. Okay. Next is area of a sector. So this is basically just proportional area of a circle. Okay, so area of a circle is pi r squared. Is it a fourth of it, sixth of it, whatever. Here's your formula: 1/2 radius squared times theta. Again, the theta has to be in radians. So we're trying to find all that area in there. Again, so we just don't think formulas come out of the math magic hat. We should try and prove these things here. So let's take two different central angles, theta and theta 1, in two different areas, area and area 1. So from geometry, we should be able to set up this ratio again. So the central angles should be the same ratio as the areas. Okay. Now, let's say this theta 1 here cuts out exactly 2 pi. So it's going all the way around the circle. That's not what the picture's showing, but if we assume that theta 1 is, the entire circle, that means the area is pi r squared, area of a circle. So therefore, all we got to do to solve for area now So we do this, you see the pi's will cancel, and 1/2 theta times radius squared. Application of that, simple little problem like this. So let's say 60 degrees of a UFO crashed in a cornfield. It's got a diameter of 70 feet. Find the area of the corn damaged. Basically 60 degrees of a UFO here. It's going to damage some corn. So we're trying to find the area that's impacted from this. 1/2 theta times r squared. Okay. We know the diameter of this UFO is 70 feet. So let's make sure we plug in 35 here for the radius. The only thing now is we need the theta. You can't plug in 60 because these equations came from radians. So another practice here, converting 60 degrees. Pi's on top, 180's on the bottom. If you remember from earlier, I said 60 degrees always correspond to 3's on the bottom. 6 over 180 is pi over 3. 1/3 of the way to 180. So go plug this in there. And however you want to give me an answer here is fine. So I'm going to go ahead and just include the pi this time because our answer is going to be ugly no matter what. So this is about 641.4 square feet of damaged corn. Okay, so that's it for our first lesson here. Runs a little bit longer than the usual ones just because there's so much new stuff for you guys here. But make sure you have some good notes, have some questions down, and we'll start building this unit circle in class here soon. See you guys tomorrow.